Prepare to be captivated by the astonishing tale of Pluto's heart-shaped feature. In a groundbreaking discovery, a global team of astrophysicists, spearheaded by the University of Bern and the National Center of Competence in Research, has unraveled the enigma shrouding this celestial marvel. Imagine the intrigue that gripped scientists worldwide when NASA's New Horizons mission revealed a colossal heart-shaped formation adorning Pluto's surface in 2015. This heart has baffled experts due to its distinctive shape, geological composition and elevation. Enter the intrepid researchers from the University of Bern, joined by counterparts from the University of Arizona in Tucson, who embarked on a daring quest using advanced numerical simulations to delve into the origins of Sputnik Planitia, the captivating western teardrop nestled within Pluto's heart. Their groundbreaking findings, recently unveiled in the journal Nature Astronomy, shed light on a cataclysmic event in Pluto's ancient past. Picture this, a monumental collision with a planetary behemoth measuring a whopping 700 kilometers in diameter, nearly twice the width of Switzerland. The impact birthed Sputnik Planitia, reshaping Pluto's landscape and revealing unexpected secrets about its inner structure. What's particularly intriguing is the divided heart phenomenon. The Tombow Regio, as it's scientifically known, captured not just public imagination but also scientific scrutiny. Cloaked in high albedo material, this region reflects light differently, giving it a luminous appearance distinct from its surroundings. Sputnik Planitia, the heart's western jewel, spans an area equivalent to a quarter of Europe, or the United States, plunging 3 to 4 kilometers below the surrounding terrain. The luminosity of Sputnik Planitia stems from its blanket of white nitrogen ice, constantly shifting and smoothing its surface in a mesmerizing dance. This ice likely amassed swiftly post-impact owing to the lower altitude of the region. Meanwhile, the eastern part of the heart boasts a thinner layer of nitrogen ice, its origins still a scientific puzzle, yet likely linked to Sputnik Planitia's genesis. Unveiling the impact's dynamics, the team's smoothed particle hydrodynamics simulations recreated the epic collision, discovering the impactor's composition and the angle of impact. Pluto's frigid core proved resilient, resisting melting despite the collision's heat. The oblique angle of impact prevented the impactor from sinking into Pluto's core, leaving a splat that has become an enduring cosmic artifact beneath Sputnik Planitia. In this saga of cosmic collisions and enduring mysteries, Pluto's heart remains a testament to the universe's boundless wonders and the relentless curiosity of humanity's quest for understanding. Remember to like and share this video if you enjoyed it, and make sure to subscribe to see how the universe unravels.